Let's learn force between multiple charges of grade 12 physics from the first chapter electric charges and fields. First you should know about electrostatic forces. These are the attractive or repulsive forces between stationary electric charges. These fundamental forces play a crucial role in many physical phenomena and technological applications. Quantitative description of electrostatic forces. Coulomb's law states that the magnitude of the electrostatic force between two point charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. The force decreases dramatically as the distance between the charges increases following an inverse law. Force can be attractive or repulsive depending on the relative signs of the charges. In order to calculate electrostatic force between multiple charges, we should know about superposition principle. The net electrostatic force on a charge is the vector sum of the individual forces exerted by all the other charges in the system. Let's consider a system contains three charges, let's say Q1, Q2 and Q3. In order to calculate the force exerted on Q1 due to Q2 and Q3, calculate the force exerted on Q1 due to Q2 and Q3 individually and take the sum. Vector addition. To find the net force, individual forces must be added vectorically, taking into account both magnitude and direction of each force. Complexity increases. As the number of charges increases, the calculation of the net force becomes increasingly complex, requiring careful analysis. Let's calculate the electrostatic force due to a system of three charges. Consider this figure or represent the origin, and this system consists of three charges Q1, Q2 is here. Let me represent. This is Q2 and this is Q3. Q1, Q2 and Q3. Three charges are there, and we have to represent the position of three charges by using vectors. So here vector R1 represent the position of charge Q1 from origin O, and vector R2 represent the position of charge Q2 from origin O, and vector R3 represent the position of Q3 from origin O. The position vectors represent the position of each charges with respect to origin. And here the distance between each charge is also represented, and the distance between Q1 and Q2 represented by R12, and this is the unit vector R12 cap. This is the unit vector which represent the direction. And the distance between Q1 and Q3 represented by R13, and the unit vector represent the direction is R13 cap. Here we consider charge Q1 and force exerted on Q1 due to these two charges Q2 and Q3. First you can see F1. This is the net force, and F12 represent the force exerted on Q1 due to Q2. That is in this direction F12, and F13 is in this direction, means the force exerted on Q1 due to Q3, that is in this direction, and the net force or the total force will be in this direction. Hope you understand the figure. Now let's write it mathematically. Force on Q1 due to Q2 can be denoted by F12. This is vector. That is, according to Coulomb's law, the force is 1 by 4 pi epsilon 0. The two charges we considered here is Q1 and Q2. And the distance between two charges is R12 square. And we have to multiply this with the unit vector R12 cap. So this is the force exerted on Q1 due to Q2, that is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12, means the distance between two charges is represented here R12 square dot R12 cap. This unit vector added to represent the equation in proper vector form. The same way we can write the force on Q1 due to Q3. Force on Q1 due to Q3 represented by F13, F13. Coulomb's law. According to Coulomb's law, we can write 1 by 4 pi epsilon naught Q1 Q3 by the distance between Q1 and Q3 represented by R13. So it is R13 in Coulomb's law, there is a square. So put the square, then the unit vector is R13 cap. So here we wrote the force exerted on Q1 due to Q3. According to Coulomb's law, we wrote this equation as 1 by 4 pi epsilon 0 Q1 Q3 by R13 square dot R13 cap. Now we have to calculate the total force F1 on Q1 due to two charges Q2 and Q3. So the net force on Q1 due to Q2 and Q3 we can write as F1, that is the sum of F12 and F13. That means F12 is here in equation 1, F13 is here in equation 2. So we just substitute the values. Here in both equation 1 by 4 pi epsilon 0 is common. So we can take this like this 1 by 4 pi epsilon 0. Then Q1 Q2 from first equation remaining terms. Q1 Q2 by R12 square dot R12 cap plus in the second equation 1 by 4 pi epsilon 0 we already taken out remaining Q1 Q3 by R13 square dot R13 cap. This is the net force on Q1 due to Q2 and Q3. Suppose there are a number of charges like 100 charges or 200 charges or say n number of charges are there. We can write this force as suppose n number of charges are there. The charges Q1, Q2, etc. up to n number of charges are there. Then we can write the total force on Q1 due to the n number of charges. That is F1 equal to. First we have to calculate force exerted on Q1 due to Q2. That will be F12 plus the same way force exerted on Q1 due to Q3 F13. The same way we can calculate etc. plus force exerted on Q1 due to nth charge. It can be 100th charge or 200th charge anyway. So that will be F1n. So in all the terms 1 by 4 pi epsilon 0 will be there. Take that as common. And other terms. First F12 means Q1 Q2 by R12 square R12 cap plus F13 will be Q1 Q3 by R13 square dot R13 cap plus etc. Plus last finally in the term F1n means Q1 Qn by R1n square dot R1n cap. That's why I'm saying if n number of charges are there, the complexity will be increases. You have to imagine if n number of charges, 100 charges or 200 or 1000 charges are there, how many times you have to add the terms like this. That's why complexity increases when the number of charges increases. And this term we can reduce as in all the terms you can see Q1 is common. In the last time also Q1 is common. So we can take that Q1 also outside. We are going to write this in short way. So Q1 by 4 pi epsilon 0. And all other terms are changing. See, the first time Q2 in denominator R12 is there. And second time Q3 denominator R13. And the next term Q4 denominator R14. Like that last term Qn is there. and the denominator R1n is there. So that terms are changing. So there we have to add the symbol sigma and consider a variable I is equal to 2 to n. Because 1 is common, we taken already outside. So we are considering the value 2 to n. Then this Q2, Q3, Q4, Q5, etc. up to Qn, that value is changing. So we have to give the variable to Qi by, and look at the denominator R12, next R13, next R14, R15, etc. to R19. So R1 is common, second digit is changing, so we can give R1I square. Same way, unit vector we can write as R1I cap. So here we express this equation in short. So this is the final equation which represent force due to multiple charges. This is the final equation. A vector F1 equal to Q1 by 4 pi epsilon 0 sigma I is equal to 2 to n Qi by R1I square R1I cap.